Hello children, welcome to Ryan Tuition Classes. We are doing Icse Physics of Standard 10. We are doing Chapter 2, Exercise 2C, okay? Now, question number 1 says, state the principle of conservation of energy. So what is principle of, according to principle of conservation of energy? According to principle of conservation of energy, principle of conservation of energy, energy is neither produced nor destroyed. It always changes from one form to other. It always changes from one form to other. Okay. In other words, the sum total of energy always remains constant. Okay. Sum total of energy in the universe remains constant. Okay. Now listen. What do you understand by the conservation of mechanical? मतलब conservation of mechanical energy बोल रहा है. Conservation का मतलब मालूम है आपको ऊपर देख रहे हो. Okay. Conservation of mechanical energy का मतलब क्या है? So please have a look at answer. According to conservation of mechanical energy, according to conservation of mechanical energy, whenever there is a change from between whenever there is a transformation between kinetic energy and potential energy, the sum total of mechanical energy remains constant. According to conservation of mechanical energy, whenever there is a transformation between kinetic energy and potential energy, of a system, then the sum total of mechanical energy remains constant. Are you getting me here? Okay. Now, state a condition under which mechanical energy is conserved. Mechanical energy is conserved. The mechanical energy is conserved only when there is no force of friction. When there is no force of friction. The mechanical energy conserved only when there is no force of friction. Okay. Name two examples. Question number 3. Name two examples in which the mechanical energy of a system remains constant. Examples. 1. For a freely falling body, the total energy on top at top, the sum total of kinetic energy and potential energy at any point of its motion. For a freely falling body, the total energy at top, the sum total of kinetic energy and potential at any point during its motion and the total energy at the instant it reaches the top are always, see, for a freely falling body, the total energy at top, the sum total of its energy, the sum total of kinetic energy and potential energy, the sum total of kinetic energy and potential energy at any point during its motion, and total energy at the instant it reaches the ground are always equal. Hence, mechanical energy is conserved. Is conserved. Is conserved. Okay. Yeah, one more part, one more example. They want name two examples. Okay. So for a freely oscillating body, the total energy for a oscillating body, the total energy at its extreme as well as at the mean position remains the same. Second example 2. For a oscillating pendulum, the total energy at its extremes as well as at its mean position always remains constant. Okay, so again this tells the mechanical energy. This tells the mechanical energy is conserved. Is conserved. Okay, children. Now with this, okay, we complete question number 2 also gets over. Now question number 3 gets over. Now to start with question number 4. A body is thrown vertically upwards. Its velocity keeps on decreasing. What happens to its kinetic energy as its velocity becomes 0? Again, I repeat, a body is thrown vertically upwards. Its velocity keeps on decreasing. What happens to the kinetic energy as the velocity becomes 0? Okay. So what happens? A body is thrown vertically upwards. So I write that a body is thrown vertically upwards. its velocity keeps on decreasing, and hence kinetic energy is equal to half mv square. Hence kinetic energy keeps on decreasing, but as the body is moving upwards, it is gaining height, hence and potential energy equal mgh. M and g are always constant, so h is increasing, it's gaining height, correct? And hence and mgp equal mgh, hence potential energy is increasing. A body is vertically thrown upwards, its velocity keeps on decreasing, and kinetic energy equal half mv square. You can say half m is constant and v is decreasing. So hence kinetic energy keeps on decreasing. But as it is moving upwards, it is gaining height. H is going on increasing, and potential energy equal mgh. Hence mg is constant, and h is increasing. Hence potential energy is increasing. And whatever, therefore, and when velocity of the body becomes zero, its kinetic energy becomes zero, but the body has gained maximum height, hence it has got maximum potential energy. And it has got maximum potential energy. See, I repeat, a body is thrown vertically upwards, its velocity keeps on decreasing. What happens to its kinetic energy as its velocity becomes zero? So I try to cut short and make it short. A body is thrown vertically upwards. Thrown here, a body is thrown vertically upwards. Okay? A body is thrown vertically upwards. Its velocity keeps on decreasing and kinetic energy equal half mv square. And we know half m is constant. Hence, kinetic energy and v is increasing. Okay, hence v is decreasing. Hence, its kinetic energy keeps on decreasing. But as the body is moving upwards, it's gaining height. And potential energy equal mgh. Mg is constant, and h is increasing. That is what it means, gaining height. Hence, potential energy is increasing. When velocity of the body becomes zero, its kinetic energy becomes zero, but has gained maximum height. Hence, it has maximum potential energy. Got it? Now, we go to the next question, children. What happens? Very simple, very easy. Okay? What it says, children. A body falls freely. Yes, going upwards, same. A body falls freely under gravity from rest. Matlab, it was at rest in the beginning and it starts falling down under gravity. Name the kind of energy it will possess at the point from it falls. Okay, it possesses potential energy. At the point from where from where it falls, from where it falls, okay? And B, while falling, whatever laws, the laws of potential energy becomes the gain of kinetic energy. Hence, it possesses both the energies, both kinetic and potential energy while falling. Now see part. On reaching the ground, at that instant, it has only kinetic energy. I hope people understand me here. We go ahead, children. Okay. Question number 6, children. Show that the sum of kinetic energy and potential energy is always conserved in the case of a freely falling body under gravity. I made this question short. Show that the sum of kinetic energy and potential energy is always conserved in the case of a freely falling body under gravity. So I say consider a body of mass m. E is at position A. Can you see this position A? Which is at a height h above the ground. Got it? The body is allowed to fall freely. Allowed to fall freely and it covers the distance x when reaches position B. The body is allowed to fall freely and it covers a distance x when it reaches position B. Got it? And then so at position B, consider body of mass m is at a position A, which is at a height h above the ground. The body is allowed to fall freely. It covers a distance x when it reaches position B. And then it falls to the position C on the ground. So now at position B, what happens? At position B, what happens, children? You can see here. At position, I'll say at position A. At position A. At position A. The body is at rest. Okay, body is at rest. The initial velocity is 0. Okay, it's having a mass m. Got it? And it's at a height h above the ground. Height above the ground equal h. Therefore, potential energy, the potential energy at A equals 0. Potential, sorry, kinetic energy at A equals 0. Kinetic energy at A equals 0 because it is at rest. Now, potential energy equal mgh. Therefore, total energy at A equal mgh plus 0. कितना हो गया बेटा mgh? This is my 1. Now at position B, u is 0 since it's falling. It has fallen and covered a distance x as it comes to B. Now v square equal, no time is involved, so v square equal u square plus 2as. So v square equals 0 square, u is 0, plus 2, a is g, and distance it has fallen to B is x. So v square equal 2gx. Why did I find v square? Because kinetic energy is half mv square. So kinetic energy equal half into m into 2gx. V square is 2gx. 2 gets cancelled. So what you have got? Mgx. Now this position B is a height h minus x above the ground. So it has potential energy equal mgh minus x. So total energy at B equal kinetic energy plus potential energy mgx plus mg into h minus x. Open the bracket. Again, at total energy at B, you got it as mgh. Given at A, total energy was mgh. Now also it got, okay? Now the body, okay, falls to position C on the ground. At position C, what is V square equal U square plus 2AS? V square equals 0 square plus 2GH, V square equal 2GH. So now I can find kinetic energy. Half m V square, V का जगह में 2GH, V square का जगह में 2GH. So mgh आ गया kinetic energy at C. Now I'm going to wrap the question, children. Now when I wrap the question, children, please try to remember, you know the question I suppose, okay? So that I'm able to wrap the question. So what I'll do, therefore, total energy at C equal, well, it has kinetic energy plus potential. Potential energy becomes 0. So this becomes mgh, okay, plus mgh, okay? Kinetic energy mgh. I hope people understood me. And potential energy will become 0 because the height from the ground is 0. So mgh. So what do you see? Therefore, this is my third point. Therefore, we see the total energy of the body remains conserved. Total energy of body remains conserved in during its entire free fall. Okay, entire free fall. I hope people have understood this sum. Okay, very important. Question number 7. A pendulum is oscillating on either side of its main position. Explain the energy changes that takes place in the oscillating pendulum. How does the mechanical energy remains constant remains constant? Draw the necessary diagram. So many things are asked about a pendulum. A pendulum is oscillating on either side of its main position. Explain the energy changes that takes place in the oscillating pendulum. How does the mechanical energy remains constant? Draw the necessary diagram. So here I've drawn a necessary diagram. See, consider a pendulum of mass m. Is oscillating. Its extreme positions are A and C, which are at a height h above the mean position B. Which are at a height h above the mean position B. Which are at a height h above the mean position B. Got it? So now listen, when I say at extreme position A, at extreme position A, okay? You know, momentary, it is at rest for a fraction of second, for a fraction of second. Hence, its kinetic energy becomes zero, and it has maximum potential energy. It has maximum potential energy because it is at maximum height. Therefore, potential energy equal कितना आएगा mgh. Therefore, total energy at A equal kinetic plus potential. How much it becomes? 0 plus mgh. So what happened? What you see is, children, please have a look at it. So it is at extreme position A, it is at rest for a fraction of a second. Hence its velocity equals 0. Therefore, kinetic energy equals 0, and it has maximum potential energy because it is at maximum height. Therefore, potential energy equal mgh. So total energy at A equal Ke plus P, 0 plus mgh. How much you get mgh? Now it starts oscillating and as it moves towards its mean position, the height is decreasing. That is, potential energy is decreasing, whereas its velocity is increasing. Hence, kinetic energy is increasing. At mean position A, at mean position B, H equals 0, therefore potential energy equals 0, and it has potential equals 0. Also, V square equal U square plus 2AS. Therefore, V square equals 0 plus 2GH. So, V square equal 2GH. Therefore, kinetic energy equal half mv square equal half into m into 2gh How much you get? mgh. Therefore, total energy at B equal Ke plus Pe. How much you get, children? mgh plus 0, I get mgh. So total energy at B, okay, is equal to, at B is equal to kinetic energy plus potential, mgh plus 0, mgh. Got it? Now, as it starts climbing to its position C, its velocity keeps on decreasing and height h is increasing. So again, so kinetic energy is decreasing and potential energy is increasing. So hence, at position C, it will have hence at position C, it will have maximum okay, you can see children, I don't have place to write, so I'm rubbing out the question, okay? Now look here. Hence at position C, it will have maximum potential energy. Therefore, it will have maximum potential energy. Therefore, see, at position C, kinetic energy equals 0, potential energy equals mgh. Therefore, total energy equal 0 plus mgh. Now get mgh. Thus we see the total energy of the pendulum at various positions remains constant, okay? Pendulum at various position during its oscillation, during its oscillation remains constant. Okay. So see here, children, once again I'll tell you answer. Consider a pendulum of mass m. Consider a pendulum mass m is oscillating. Its extreme positions are A and C. which are at a height h above the mean position B. Now, at extreme position A, it is at rest for a fraction of a second. Hence, its velocity equals zero. Therefore, kinetic energy equals zero. And it has maximum potential energy because it is at a maximum height h. It is at a, therefore, potential energy equal mgh. So, total energy at A equal ke plus mgh, 0 plus mgh, mgh. Now, it starts oscillating, and as it moves towards its mean position, the height is decreasing. That is, potential energy decreases, whereas its velocity is increasing. Hence, kinetic energy is increasing. So, at mean position B, height is zero. Got it? Potential energy becomes zero. Also, v square equal u square plus 2as. So, v square equals 0 square plus 2gh. V square is 2gh. So, kinetic energy equal half mv square. Half in m into 2gh. 2 gets cancelled mgh. So, total energy at B equal ke plus p mgh plus 0 mgh. Now, as it starts climbing to its position, its velocity keeps on decreasing. Height h is increasing. So kinetic energy is decreasing. Kinetic energy is decreasing and potential energy is increasing. Hence, at position C, it will have maximum potential energy. So at position C, kinetic energy equals 0, potential energy equals mgh. So total energy is n. Thus, we see the total energy of pendulum at various positions during its oscillation remains constant. Okay, children? So we go to the next question. Question by A. A pendulum with bob B of mass m is oscillating on either side of its resting position A between the extremities B and C at a vertical height h above A. I hope people are understanding. There's a pendulum, mass of the bob is m. This bob pendulum is at the mean position A. It is oscillating between the extreme positions B and C, which are at a height h above its mean position. What is the question is, what is the kinetic energy K, potential energy U when the pendulums are at different positions A, B, and C? See, at mean position, okay, when it is oscillating, at mean position during oscillation, its velocity, the bob has maximum velocity v. Got it? Initial velocity u was 0, therefore v square equal, and s is h, so v square equal u square plus 2as. A is g. So what will happen? V square equals 0 square plus 2gh. So how much you get? V square equal 2gh. So it has, because of motion, at A it has only kinetic energy. So kinetic energy is given by the formula half mv squared. So क्या आएगा बेटा? Half into m into 2gh. तो आपका 2 to cancel हो गया mgh. तो आपका k आके mgh आके potential kinetic energy is mgh. अच्छा, what is potential energy u? Potential energy u will be 0 since its height is 0. Height equals 0. Okay, from the ground, the height is 0. From its mean position, the height is 0. Got it? So naturally, it has no potential energy at all. Got it? At position A. Now, at position B, suppose at position B, while oscillating, during oscillation, as it reaches B, it comes to rest. Okay? That is V equals 0. Hence, K equals 0. Correct? But U equal potential energy equal mgh. Got it? K equals 0, but U equal mgh. Okay, because it is at maximum height. Okay, at position C, just like this, the way what you wrote for A, same comments you'll write. See, at position C, during oscillations, as it reaches C, its velocity, it comes to rest. That is V equal 0. Hence, K equals 0. But it is at maximum height, so it has maximum potential and U equal mgh. Correct? So I just said it. What is the kinetic energy and potential energy at various positions of this pendulum? Okay, I hope people understood this question. Now we go to the next question, children. What do you mean by degradation of energy? Explain it by taking one example of a daily life. See, very nice question. What do you mean by degradation of energy? Explain it by taking one example of your daily life. I forgot recording it. That's why I wrote the answer and I'm recording it. Okay, doesn't matter. What do you mean by degradation of energy? Explain it by taking an example of your daily life. See, when energy is getting transformed from one form to another, a part of the energy, not everything, a part of the energy gets converted to a non-productive form. This energy is called a degraded energy, and the process is called dissipation of energy or degradation of energy. But example, they wanted to give an example, okay? Right, when we cook a food over a fire, a major part of the heat energy gets radiated in the atmosphere. Some part of the heat energy gets used up for cooking food, but a major part of the heat energy gets radiated in the atmosphere and are of no use to us. This energy is called a degraded energy. Similarly, whenever we use suppose we use electricity for lighting a bulb, so you can see that heat energy is produced and that heat energy is getting radiated out, wasted, okay? So that energy, the bulb glows, giving us light, okay? But there is an heat energy produced. That heat energy is getting wasted. We can call that as a degraded form of energy, okay? Anyhow, now we go to the complete the following sentence. The conversion of a part of energy into an undesirable form is called dash. So it is called degradation of energy. You can also call it as dissipation of energy, okay? Degradation of energy or dissipation of energy. Got it, children? With this chapter gets over, children.